all know him, and we all love that beard. Dmitri Mendeleev, father of the periodic table. But who else contributed to the discovery of the table? And who else shaped it in modern times? Find out next. In the early 1800s, chemists noticed that certain trios of elements like calcium, strontium, and barium behaved almost identically in chemical reactions. Chlorine, bromine, and iodine were another trio. This implied that these elements were all related somehow. This was also the first hint that something like the periodic table existed, because chemicals could now be grouped into different families. A French geologist took the next big step in 1862 when he arranged most of the 60 or so known elements into a rough table. Unfortunately, when he published a paper on his work, he emphasized the applications to geology, not chemistry. Worse, the diagram was pretty complicated, with the elements running diagonally down the page, and the editor couldn't figure out how to reproduce it. As a result, it never appeared in print. Imagine trying to learn about the periodic table without seeing it. No wonder no one paid attention to his breakthrough. English chemist John Newlands had equally rotten luck in 1865. Back then, no one knew the noble gases existed, so the top rows of his rudimentary periodic table repeated after 7 elements. Newlands whimsically compared these 7 to the do, re, mi, fa, sol, la, ti, do of the musical scale. Colleagues, however, didn't find his Nickelodeon chemistry amusing. Many also distrusted his work as too theoretical, and it languished. Several other chemists made rough periodic tables in the 1860s as well, but only after Dmitri Mendeleev published his table in 1869 did the table gain traction. Why? Well, most importantly, because Mendeleev left holes on his periodic table and predicted that new elements would be discovered, predictions that proved correct. This showed that the periodic table wasn't just a clever arrangement of elements, but had real scientific power. Over the next few decades, chemists added several new elements to the table, including the entire column of noble gases. All the while, though, one question kept nagging them. Why did the elements fall in the order they did? They knew that most elements appeared in order of increasing atomic weight. But every so often, like with nickel and cobalt, the weights were reversed,
with the heavier element appearing first.
No one could explain why until 1913. That year, Henry Moseley, a British physicist, began probing elements with a new tool, a beam of electrons. As we know today, when the beam strikes an atom, it punches out one of the atom's own electrons, leaving a hole. Since nature abhors a vacuum, other electrons within the atom rush in to fill the gap, movement that releases X-rays. Moseley found a mathematical relationship between the wavelength of the X-ray and the number of protons an element has. Excitingly, the number of protons also equaled the element's spot on the periodic table. In other words, an element's identity didn't depend on atomic weight, but atomic number, the number of protons in its nucleus. Reversals like nickel and cobalt suddenly made sense now. Moseley's work also led to 2 other important results. First, chemists could now determine exactly where holes still existed on the table and what elements remained to be discovered. Second, it provided strong evidence for an exciting new theory of atomic structure, which said that atoms consisted of a compact, positively charged nucleus with electrons swirling around it. Overall, Moseley's experiment is one of the most important in chemistry history. Sadly, Moseley had little time to celebrate his success. When World War I broke out, he insisted on joining the military and was shot during the doomed Gallipoli campaign of 1915. He was just 27. One colleague moaned that the loss of Henry Moseley by itself made the war one of the most hideous and most irreparable crimes in history. After Moseley, chemists continued to fill in holes on the periodic table. But nothing changed fundamentally until the 1940s. During that decade, chemists associated with the University of California at Berkeley, especially Glenn Seaborg, began making artificial elements beyond uranium, element 92, the heaviest element in nature. They quickly extended the table all the way into the 100s. Eventually, Soviet and German teams developed methods for making artificial elements as well, and Seaborg's team got into some pretty heated disputes with them over who deserved credit for discovering certain elements. But there's no dispute that Seaborg shaped the table more than any other modern chemist. He even got one element named after him, number 106, Seaborgium. And when I say that Seaborg shaped the table, I mean that literally. Until the 1950s, most periodic tables looked like calendars with 8 days in the chemical week. Some elements even had to share spaces on the table. Seaborg decided to widen the table, giving the transition metals more room. He also moved the lanthanides and actinides below the table, giving it the classic look it has today, like a castle with turrets and a moat. The periodic table continues to evolve today. In December 2015, chemists officially added elements 113, 115, 117, and 118. And periodic table lovers worldwide are buzzing about what their names will be. Adding those 4 elements also squared off the table's bottom row, giving it a nice, complete look. In fact, given that the other elements were all discovered in haphazard order, we've never had such a nice, complete periodic table before, and we might never have such a complete table again. Chemists are already working to add more new elements, which would appear in the 8th row at the bottom. But because elements at the bottom of the table are so fragile, most disintegrate after a fraction of a second, no one knows how many more we can create, even with advanced technology. That 8th row might never be finished. So take a moment to appreciate the current periodic table. It will always be important for science, but right now is probably the most handsome it will ever get.